Okay. Oh my gosh, yes you do. Thank you for reminding me. I was staring at it on my desk and just not processing. Thank you, Jesus. Put the Chromebooks away. All right. Let's start with a review. If I'm looking at a right triangle, and I'm looking at a right triangle that's not part of the unit circle, just a regular right triangle, I have to label the sides. I want to find sine of an angle. Sine is what side over what side? I said opposite over hypotenuse. Very good. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. You're right, those relate to x and y in the unit circle, but now we're focused on right triangles outside of the unit circle and in the real world. And so these definitions are going to be more helpful in these types of problems. So a quick reminder, if you are asked to find a missing side length in a right triangle or a real world situation, you should identify the given angle and label any sides with their given side lengths. In order to find a missing side, you need a side and an angle or two sides. So you can use the Pythagorean theorem. We're practicing side and an angle questions because we want to use trig to solve them. If I have two sides and I want the third, Pythagorean theorem is like math from years ago, right? You already know how to do that. We're experts on Pythagorean theorem. So I've slapped numbers in my picture, labeled my angle, labeled any sides that had lengths on them. Next step, I need to label my opposite, adjacent, and hypotenuse sides. Relative to the angle that I identified in the first step. I should have identified an angle that I have a number for other than the 90 degrees, one of the two acute angles. And I'm going to label all of my sides relative to that angle of interest. Once I've done that, I'm going to select a trig ratio that involves the unknown side. And one of the sides that I know the length of. So an unknown side and a known side. Meaning in my trig ratio, one of those numbers, or one of those values will have a number, one will be a variable. So an unknown and a known. And I'm going to set that trig ratio up. And then I'm going to solve for the missing side length. Multiplication or division, depending on whether the unknown is on the top or bottom of my fraction. We're going to do nothing but examples today. Yay, we like examples. I'm going to scoot you up here. First example says, find the unknown sides of the triangle shown below. And they did the labeling for me. How nice of them. They labeled a 30-degree angle. They labeled sides A and C. They labeled the side opposite the angle as 7. So I have one known side and two unknowns. And notice it said find the unknown sides plural. I need to find both A and C. So I'm going to do step 1 is already done for me. Identify angle, label the sides. Step 2, label opposite, adjacent, and hypotenuse relative to that angle. So side 7 is my opposite side. Which side is my adjacent side? A, very good. Which means this last guy, my longest, must be my hypotenuse. Perfect. And we'll start by finding side A. So I know that side A is the adjacent side, and I know the opposite side. So I want a trig function that uses adjacent and opposite. Which are the 3 trig functions? Tangent. Perfect. I know tan is opposite over adjacent. So for us, tangent of 30 degrees is equal to 7 over, that is the worst 7 I've ever drawn, 7 over A. Set up my ratio. Now I got to solve for A. It's in the bottom of my fraction. How do I get it out of the bottom? Multiply. Yeah, let's multiply both sides by A. So A times tangent of 30 degrees equals 7. I don't want A tan 30, I just want A. How do I undo that multiplication? Very good, divide by the thing I want to get rid of. So both sides by tan 30. So here that's going to cancel. So A is equal to 7 divided by tangent of 30. On your calculator, make sure that your calculator is in degree mode. And we want to know what 7 divided by tan 30 is. And we're going to round to the 10ths place today. 10ths place. Raise your hand when you've got a number. Jesus, what do you got? 12.124, which I rounds to 12.1. Can I get a thumbs up if you agree with Jesus? I see thumbs up around the room. Very good. Perfect. So now in my side, I know that this side is 12.1. But I'm not done with the question. As the question said, find all of the missing sides. I have a question for you. How should we do that for C? What can we do to find C? There's 2 choices. Very good. A squared plus C squared equals, A squared plus B squared equals C squared. So we could use Pythagorean theorem, or we could set up another trig ratio. My preference in this case is to set up another trig ratio. And here is why. That number is a rounded number. If I use Pythagorean theorem with it, I am introducing extra rounding error to my answer for C. So if I am doing a computerized assignment, it is better to use a second trig ratio to find that missing side. You'll have less rounding error. You'll be more likely to get the answer the computer's looking for. Both methods are correct. If you did Pythagorean theorem here on your test for C, I would not mark you wrong. But you have to recognize there's going to be rounding error there because you're inputting something that was rounded to begin with. Yeah? So I'm going to do the trig method ratio. I need a trig ratio that involves the hypotenuse. I have the other side, so it doesn't matter which one. Sine. I like sine, so we know sine is opposite over hypotenuse. So sine of 30 equals our opposite side is 7 over C. And you will notice something. The structure of that equation looks an awful lot like the structure of the equation for A. Look at what happened to my variable and my trig function. It looks like they just switched positions. I multiplied to get C on top on the left. I divided by sine to get sine on bottom on the right. I can do that all in one step. C equals 7 over sine 30. Because I know that's what's going to happen. I just did that same math with a different fraction. And we grab our calculator. And I get a nice pretty whole number. I get 14. I would like you to take a minute in your small groups and find C using a squared plus b squared equals c squared with those two sides and see what you get. I'm going to give you about 2 minutes. Don't judge me. That's a good question. Where is your calculator? Estrella, what did you get? Yeah, something that rounds to 14, 13.9 something, but not exactly 14. So if you use Pythagorean theorem for that third missing side, you're going to have rounding error. Trig functions give you exact values, or closer to exact values. Good. Good, we're going to try another one. Example 2 says a right triangle has one angle of pi over 3 and a hypotenuse of 20. Find the unknown sides and missing angle of the triangle. So, suggestions on what I should do first. Yeah, let's draw a picture. I don't have anything to label, so we're going to draw a right triangle. It is not to scale because I have trouble drawing with a pen on the board. They told us the hypotenuse is 20. I know the hypotenuse is opposite the 90 degrees. So this must be 20. I'm going to label my other sides A and B, because those are usually the letters we use to represent legs of a right triangle. I'm going to label them relative to my given angle. My given angle is up here. Which side is my opposite side? B, B, A. Adjacent side? B. Because we know 20 was our hypotenuse. That's how we label it. Good. Very good. We want to find the missing stars. Which one? Shards. Sides. I can talk. I promise I can talk. Which missing side do we want to find first? A. I like that. I'm in favor of alphabetical order. A is my opposite side. I have the hypotenuse. So which trig function involves opposite and hypotenuse? Perfect. So sine of pi over 3 equals, our opposite side is A, our hypotenuse is 20. I want to solve for a, what do? Multiply by 20, yeah, good. I like that suggestion. Because that way these guys cancel. So a equals 20 times sine of pi over 3. What setting should my calculator be in? Radians, very good. You need to change it to radians before you do your math. I get 17.3 something, 17.30 something. See some nodding? That's a good sign. That makes sense. I know my leg should be shorter than my hypotenuse. It's shorter than 20. That's a good sign. Good. So I now know that 17.3. I gotta find b. Somebody have a suggestion on how to do that? Cosine, very good. Cosine is adjacent over hypotenuse, and b is our adjacent side. So cosine pi over 3 equals b over 20. Looks almost identical to the one we just solved. I'm going to multiply both sides by 20. You get 10. Am I done with the question? No, because they asked us to find the missing angle too. I have a 90 degrees, which I know is pi over 2. I have an angle of pi over 3. I want to know what that missing angle down in the bottom is. So I know that 180 degrees, which is the sum of the angles in a triangle, is equal to pi. So I need to know what pi minus pi over 2 minus pi over 3 is. That will give me this angle down here. And the best way to do that is let's put that first one over 1 and find a common denominator. What numbers or number do 2 and 3 divide evenly into? 6. Yeah, I agree, 6. So 6 pi over 6 minus, and then I have to multiply 2 by 3. So 3 pi over 6, and I have to multiply 3 by 2. 2 pi over 6. So 6 minus 3 minus 2. Yeah, it's 1 pi over 6. So this angle down here is pi over 6. Yeah. In terms of our picture of the unit circle, I know that the pi over 6, pi over 3 form 90 degrees. That forms a complete quadrant. Plus another 90 would give me 180. So it makes sense if I have pi over 3, the missing is pi over 6. Yes, Owen? What did I want? What? Oh, so this is the equivalent of 180 degrees, which is the sum of the angles in the triangle. This is my 90 degrees, right? This is my right angle. This was my given angle. And then I'm finding the missing. Yeah. It is the same process we use with degrees. It just looks weird because it's in radians. But the process is the same. I know the 3 angles add up to 180, so if I have 2 of them, subtract to find the third. Good. Very good. My hope is that feels familiar. Can I get a thumbs up if yes, thumbs down if no? I see mostly thumbs up. Some of you are a little less obvious about it. Some of us aren't even paying attention. Face. I don't see anybody crying. That's always a good sign. Good. So the reason we do that is so we can solve real world problems. That's the whole point. So in real world problems, We are often using right triangles to find missing distances. And we're typically doing that with the height of things, heights of buildings, heights of trees, heights of humans, heights of things. We also look at the angle that is made for the line of sight. So if I'm standing at ground level and I look up to the Eiffel Tower, there is an angle of elevation between the ground and my line of sight to the top of the Eiffel Tower. And we call that angle of elevation. So angle of elevation, I'm on the ground, I'm looking up, the angle that's between the ground and my line of sight. Angle of depression is a similar idea, except now I'm standing at the top of the object and I'm looking down at the ground. So the angle of depression is up here. You will notice that they are alternate interior angles for two parallel lines, which means the angle of elevation and depression in a single picture will be same number. So it doesn't really matter if you phrase it in terms of elevation or depression. Elevation is more typical with things that you're measuring the height of on the ground. Depression is more common when you're talking about airplanes in the sky and looking downward towards a landmark. The idea is very similar. You should start by drawing a picture that represents the situation. That picture should include a right triangle somewhere. For example, in this picture with angle of elevation and depression, I can see a right triangle here. I should label it just like I do in a regular missing side problem. Label the known angle, label the known sides, label the opposite, adjacent, and hypotenuse relative to the given angle. Come on, pen. And once you've done that labeling, we can kind of remove this from reality and treat it just like a missing side trig problem. Pick the appropriate trig function. One piece of the ratio is unknown, one piece is known, and then solve for the unknown. The only added catch is when you write your answer, because the original problem came from the real world, your answer should have units on it. Is that missing distance in feet or meters or inches? Make sure you slap those on your answer. Let's try some. All right. Someone with a nice loud voice be willing to read example 3? I've been talking all day. I'm tired.
I'll do it, Mr. Geller.
Oh, thank you. I'll have you do 4, Rolly. Thank you, Jesus.
Find the height of a tree. A person wants to point 30 feet from the base of the tree. They measure an angle of 57 degrees in a line of sight to the top of the tree and the ground. Find the height of the tree.
Very good. Thank you. So first thing, I'm going to draw a picture. This is not an art class. Do not judge my artwork. So tree, X marks the spot. X is where I'm standing. I'm going to go over this picture in red to mark the right triangle that's formed from the top of the tree to the bottom of the tree to where I'm standing. I'm going to go in and I'm going to label the information I was given. How far am I standing from the tree? 30 feet. So I know this is 30 feet from the base of the tree. Very good. What else am I told about this picture? 57 degrees between the ground and my line of sight. That's this angle down here, my angle of elevation. Good. That looks like all the numbers I was given. What are they asking me to find? Height of the tree. They're asking me for this side of my right triangle H. I need to label the sides of the triangle relative to the angle I was given. So opposite side, adjacent side, hypotenuse. And I need to choose a trig function that involves the unknown side and the known side, opposite and adjacent. Is tan, very good. So we know tan of 57 degrees should be the opposite side, which is H, over the adjacent side, which is 30. Alexis, what do I do next? Multiply by 30. Very good. Opposite operations, reverse PEMDAS. Very good. We get H equals 30 tan 57 degrees. What mode does your calculator need to be in? Degrees. Did you get a number, Ziza? What did you get? Not 1.9, we rounded to 2. Yeah. 46.2 what? Feet. Very good. If we started with feet, we end with feet. So the tree is 46.2 feet tall. Good. Very good. Questions on example 3? No. Hopefully feels familiar. Oh, and would you do me a favor, read example 4 real quick?
How long will ladder have you to reach the window sill 50 feet above the ground, provided that
Very good. So I know I've got a ladder resting against a windowsill. So basically I have a building. I have the ground. I have a ladder leaning against that building. Very exciting 2D drawing here. There's a reason I did not major in art. I'm going to sketch the right triangle that I see in the picture, which is ladder to floor, floor to where the ladder touches the floor, and then the length of the ladder itself. I'm going to start sticking numbers in there. So what information did they give me? The height of the ladder relative to the ground. Yeah. How far along the building is it sitting? It's 50 feet from the ground to the windowsill. So this, come on, pen. That is my 50 feet. What else did they give me? An angle relative to the ground. That's this guy down here, 5 pi over 12. And what side am I looking for? Side along the ground or the length of the ladder? Length of the ladder, yeah. They asked me for length of the ladder. I'm going to label that L because that makes sense for length of ladder. Yeah. Relative to that angle, opposite adjacent hypotenuse. So my angle is down here, opposite, adjacent, hypotenuse. I have the opposite side. I want the hypotenuse. Very good, Cecil. Sine of 5 pi over 12. Try that again. Is equal to, and then opposite is 50 feet. Adjacent is, or not adjacent, hypotenuse is L. I want to get L by itself. I'm going to have to do two things. What do I do first? Multiply by L to get it out of the bottom. And then what's next? Division by sine, yeah. So I get L equals 50 over sine of 5 pi over 12. What mode does your calculator need to be in? Radians, very good. All right, Emiliano, what'd you get? Round it to the nearest whole number. Nearest whole number.
No, it's radians.
It's got pi in it. It's definitely radians. We seem to be some disagreement at the back table. Ali, what'd you get? 51.8, which would round to 52. Yeah. I would need a 52-foot long ladder in order to make that angle with the ground and reach 50 feet up the building. Yeah. Good. Very good. I would like you to take a couple minutes in your small group, do the same thing with example 5, and then I'm going to have a volunteer come up and do the problem for us on the board. Give you about 4 minutes, 5 minutes. So let's think together. Everyone has correctly labeled this height as 400, which I agree. We have correctly labeled the distance from the building to the monument as something, whatever we want to call it. What I'm going to do is I'm going to go ahead and draw two right triangles. Yeah. There's one from the window to the building and up. Yeah. That's one right triangle. I have another right triangle that starts at the window, goes to the monument, and comes down. And there were two different angles that were given. So the one for the top triangle from the window up is what? 18 degrees. Good. So why can't I write today? 18 degrees. Good. What about the bottom? 3 degrees. Yeah. Not 33. Come on, Mr. J. In that picture, two different right angles. I don't know what either one of these side lengths are. But I do know they add to 400. So I'm going to call this side length x. And if this side length is x, what is this side length? Yeah, the difference between x and 400. Because I know if I add them together, I have to get 400 back because the whole building's 400. I now have two right triangle problems that involve the same two letters, x and d. So I'm going to set up two trig ratios. For both of them, it's going to be the same trig ratio. If I'm looking at the angle, d is which side relative to the angle? Touches the angle, it's which side? Adjacent. So d is the adjacent side I'm looking for. What are these sides over here relative to that angle? Opposite. So I have opposite and adjacent involved. So which trig function should I use? Good. In both cases, I'm going to have a tangent function for 18 degrees. I'm going to have a tangent function for 3 degrees. It's fun. This is fun. We like problem solving. Good. 18 is the top triangle. That's me looking up at the top of the monument. My opposite side is 400 minus x. My adjacent is d. Did I do that correctly? I think I did that correctly. For my tangent of 3 degrees, my opposite is x, my adjacent is d. My suggestion, and I will give you a couple minutes to work on this in your small group, is I would solve this tangent of 3 degrees equation for x and then plug that expression in here. I'm going to give you a couple minutes to do that in your small group, and then we will pick up where we left off today, tomorrow at the beginning of class, and finish this together. Yeah? But spend the rest of the class period with your group. How does that algebra look? Oh, well, that's a bummer. Have a good rest of your Monday. Don't forget, week 2 homework's due today. I'll see you tomorrow.